Let me also show you different wire sizes. So once again, this is solid core 22 gauge wire. This is stranded wire. And this is 16 gauge. And here is another stranded wire example, but this is 12 gauge. Once again, you certainly should be able to see the increase in wire diameter as the wire gauge size gets smaller. So there's 22, 16 gauge, and 12 gauge. And once again, the difference is not only the diameter of the wire, but also the current carrying capacity. So this 12 gauge wire has and you can look this up in a table too, has a current carrying capacity of 20 amps, 16 gauge, 13 amps, 22 gauge, 6 amps. So depending on your application, that will determine what wire size you need to use. But everything in the curriculum book, you're going to be using 20 to 24 gauge wire. So you'll be using a wire size. This is 22. The other thing I wanted to illustrate was using a multimeter or voltmeter, but in this case we have a multimeter because we can use this to measure multiple electrical quantities. So we could measure, and you'll notice you got a screen, and then you've got a rotary dial with some symbols. But with this device, we can measure, this multimeter, we can measure voltage, we can measure current, which we won't do in any of these activities in the book. And I will utilize this a couple of times throughout the various activities, trying to incorporate this. So if you've got access to a multimeter around the house, or can get access from somewhere else, certainly I would encourage you to use it because it is a very common, very practical piece of diagnostic equipment anybody working with electronics utilizes significantly. But just to give you an example, a couple things. Let's measure the voltage of a battery. In this case, I've got a D-cell battery. And you'll notice you have two voltage symbols or voltage labels here on the dial, on the meter. And one has a wavy line across the top, and one has a straight line. What the wavy line has to do with AC, and you can see it on the screen also. So this would be measuring AC or alternating current voltage, which we're not going to be dealing with in this book. We're going to be dealing with direct current, which means we're using batteries. So here, and you see that is reflected on the screen. It's showing now we're measuring voltage, DC voltage. And how do we use this? Well, once again, here's the positive side. So I'm going to take my red lead, put on the button side or the battery in the positive side. This is a D-cell battery, so it should roughly read about 1.5 volts. In this case, it's reading a little more than 1.6. What if I switch the leads? I put the positive lead on a negative terminal. All you're going to get is a negative value. You still have the same value of voltage. It's just now I've just changed the polarity. Now it's reading negative. What about a AAA? It's got a button on it too. You can see the positive size label. This should read roughly 1.5 volts also, assuming the battery is good. And that's the other thing you can do. I know a lot of people have a drawer full of batteries. You can certainly use your multimeter to determine which ones are bad and which ones are good. 9-volt battery. You have a plus label on the case, and that is with the small button. And it is reading 9.33. And once again, if I switch the leads, I should simply see a negative value, negative 9.33. All right, so that I'll try to incorporate this in multiple activities, and that gives you a little quick overview on how to use a multimeter. Okay, so I'll kind of give you a brief introduction to some of these items you're going to see. And once again, there are approximately 13 hands-on activities, and you will see other videos, and there'll be multiple instructors involved, and I will do a few myself. So having said all that, I will stop, and the next video you see will actually have you building a circuit.